This is GATE 93 question. They are asking, consider a system having m resources of same type, which means they are now saying we don't know about the number of resources. It is some variable, not any given constant. And then they are saying that these resources are shared by three processes A, B and C, which have peak demands of 3, 4 and 6 respectively, which means they are saying that we are actually using this three processes A, B and C, and which have the peak demand of 3, 4 and 6, which means A needs 3, B needs 4 and C needs 6, and we don't know how many resources are required. Then they are saying for the deadlock free operation, will if you don't want any deadlock, then what will be the value of m. They are not actually asking for the minimum value of m. They have already given some options, and now you are supposed to verify which one is going to be the deadlock free operation. So in order to solve this, there are two ways. One method is you go with the options and then you prove that given these options deadlock is possible and only one option deadlock is not possible. That is always fine. Otherwise, the other method is we can find out what is the minimum number of resources required for which there is no deadlock. In order to answer this, you have to find out the reverse one, right? What is the maximum number of resources even after allowing which there will be deadlock, right? So now I am trying to find out what is the maximum number of resources required so that deadlock will still be there, right? So how to find it out? Now give each process the number of resources they are asking for except one. Just hold one back so that this process will wait for that one resource and will get involved in the deadlock. Therefore, if you watch it, the number of resources required will be 2 can be allocated to this and hold back 1, plus 3 can be allocated to this and hold back 1, plus 5 can be allocated to this plus hold back 1, right? Therefore, even if you allow these many resources, still there will be deadlock, because if A takes on 2, B takes on 3, C takes on 5, still they will be waiting for one more resource, and therefore all of them will be in the deadlock. So the maximum number of resources even after giving which there will be deadlock possible is how much? 10. So even if you give 10 resources, there will be deadlock possible. Then what is the minimum number of resources for which there will be deadlock free operation? If this is the maximum number of resources for which there will be deadlock, then if you add one more, definitely there will be no deadlock, isn't it? So minimum number of resources for which there will be no deadlock is 11, right? So answer is either 11 or anything greater than 11. See, with using 11 resources, if there is no deadlock, that means if I have 11 resources, there is no deadlock, then anything above 11 there will be no deadlock, isn't it? So that is why the answer is 11. 11 or anything above 11. So A, B and C options are less than 11. Only option which is above 11 is greater than or equal to 11 is D. So but then it is the minimum, not the minimum answer, but then in the options you could pick it up. Got it? Or other way to solve it is, you can prove that even if I have 7 resources, deadlock is possible. How? Maybe you assign 2 here, 2 here, 2 here, and maybe 1 to this, 1 to this B. Then 7 resources are not going to be enough, right? And what about 9? You assign 2 here, and maybe 3 here, and maybe 4 here. Then this deadlock is possible, right? So likewise you can prove it. Otherwise you can just do it the way I did it. Anyway, both the answers are, whatever way you do it, the answer is going to be D. Depends on which one is intuitive for you, which one is easy for you. Okay, fine.